All right, so in this tutorial, we're just going to look at some different ways in Rhino that we can draw and manipulate surfaces. As you may recall from our previous in-class tutorials, we were taking line work that we had imported from CAD drawings, flat line work, and we were simply, for the most part, extruding those lines up into surfaces that were creating 3D space. So for example, if I were to draw a line here, extrude curve is the command that we were generally using. And I could extrude that up into whatever height surface I wanted. So as you might suspect, there are many different ways to draw and create surfaces in Rhino. So let's look at a few others here, just very briefly, that hopefully will inform some of your more detailed modeling exercises with your precedent projects as the weeks go on here. So I'm just going to go ahead and delete that line that I just drew, and I'm actually going to go over to the side panel here and draw a control point curve. So just left click on that curve command so that I can get a little bit more dynamic of a shape here to kind of illustrate the point of these different ways to draw surfaces as we go. So I'm just going to draw a few points on in space here to give it some curvature. If I were to turn the points on, you could see I've actually clicked 5 different times here just to give it a little bit of shape to it, and I can adjust that by dragging these control points, but for the moment this will serve just fine. So as we just looked at, I could extrude this, extrude curve into whatever height surface I would like. I could adjust this using some of the other commands that we've used in class, such as scale 1D. I could turn the gumball on and actually slide it around if I wanted to in space. I could rotate it, make it larger or smaller by dragging these various control points. I could stretch it. But again, for now, I'm going to keep gumball off. Let's keep gumball on for the sake of this exercise, just to, again, kind of illustrate the different ways that we can manipulate these surfaces. So you'll notice I moved this up into space, so I'll just put this back down at the 0 in the Z direction, and we'll just move him off to the side for a second, but we're going to still use this curve to show a couple different ways that we can extrude a surface or create a surface. So another way that I could create a surface that we also started to touch on in class, and that's shown in another tutorial here, is a loft. Very useful command, basically, that requires multiple different curves to kind of extrapolate the shape of a surface that it will pull itself through. So for example, if I were to just copy this up, this curve that I've made, I can constrain the vertical by clicking yes if I'd like. So we can just have this be at any point in space. So now I have, in this case, 2 identical curves, and if I type loft, and then I click on these curves, it'll create a surface that's between these 2 curves that have been drawn, and there's some options here for different ways that it'll create the surface. It's not going to be as apparent just with these 2 curves that are identical, but let's say, let me cancel out of this real quick. Let's manipulate the curvature on this top curve a little bit. So if I turn my points on, let's drag these around a little bit. Maybe this gets a little bit shallower here. So now, if I were to look at this from above, actually, let's even do it a little bit more. Let's have that be out this way. So now if we look at this in plan, you can see that the surface has been manipulated and dragged in a different way than the one at the bottom. So now if we were to loft this, you're going to see basically it blends the points from here to create a surface that fills the gap. So if we click OK, that's one way that it completes the surface. Let's turn our ISO curves isocurve density up a little bit. Maybe at 2 for now, that's fine. Okay. So that's one way to loft this, and you'll notice if I just delete this and loft it again, and this option box comes up. That was a normal loft. So if I needed to, I could also loft this in different ways that again are going to come into play more when I have multiple curves that are beyond 2. So right now you'll see as I go through these different options, it doesn't appear that anything is changing. And notice that I'm clicking preview to see what happens. So you'll notice on developable, that one's attempting to try to make that curve, which is doubly curved, into something that you could, in theory, print on a piece of paper and fold into a shape in real life. So it's trying to logically flatten out the curve, which in this particular case, there's too much curvature to the surface, so it's not possible to make a developable surface out of it. So let's ignore developable for the sake of right now. But as I said, if I go back to normal here, any of these other options for lofting don't really show a difference in how these two curves connect. So like I say, let's cancel out of this again. And if we draw a third curve, I'm just going to copy this one down to about the midpoint. And then we're going to slide some of these points around again. So we have a third kind of reference for the new surface to extrude itself through. So now if I do loft and I choose each of these curves in order, you'll see that it's now pulling out through, the surface is now pulled through all three of those curves. So if I were to change the normal here to loose, click preview, you can see that the surface is still created, but it's using that middle curve as kind of a reference point that it's a little less strict in adhering to with the loose command. If I do tight, as you might imagine, it's going to try to hit each of the points along that line so that it's a little bit more accurate to the lines that I've drawn. Straight sections is basically saying, okay, at any curve that's in between the top and the bottom, it's actually going to meet exactly up to that point. It's as if I almost lofted twice. You'll see that it actually has a ridge to it here on the middle part. So again, sometimes this is useful depending on the operation that you need to perform for modeling. Sometimes you'll want it to more closely adhere to the line work and kind of seamlessly and smoothly extrude itself through. So that's normal or loose. And oftentimes there's going to be a combination of these things as you're using this command. So another thing to point out here, if I were to cancel this, and if I were to try to loft this and choose the curves actually out of order. So when I say in order, I mean if you want the surface to be kind of smoothly extrapolated across these three control curves like we just did, you need to choose it kind of in sequence from bottom to top, like that. If we choose it, let's say top or bottom, top, middle, it'll actually try to loft the curve from here to the top to the middle, and you can kind of see already that there's something kind of funky about it. It tries to get up there and then it comes back down, and it's really not creating a nice surface. And you'll see this on each of these. So in this particular case, the loose command, it's using this as the second reference point. So it's almost draping the surface up and then pulling it back down. So again, depending on what the modeling exercise is or your particular troubleshooting need, the order of the curves is important to keep in mind when you're creating these surfaces with loft. So let's just go back and loft, like I said, a simple surface here. We'll just use it as normal. We'll click OK. And just move this off to the side, just so that we have it as a reference point for later. Okay, so another way that we can create a surface, and again, can be very useful depending on the needs of the model. Let's say we have, I'm just going to delete this curve for now, or we'll hide it. So the sweep command is basically what the sweep command does is it uses multiple different curves in different orientations to create a surface, kind of like Loft, but rather Loft kind of is using the full extent of multiple different curves that are not touching one another to create, to kind of pull a shape through. Whereas Sweep, let's just draw a line, again, vertically oriented. Oops. Kind of vertical to our curve that we made at the beginning here. So it's just a vertical line. So now if I were to type sweep 1, and we'll look at sweep 2 as well in a minute, but sweep 1, so that means sweep 1 rail. So what that's asking me to do is I click enter, and it asks me to select a rail along which another shape that we've referenced will kind of drag itself to create a new surface. So in this particular case, I want my rail to be the bottom curve. And then as soon as I click that, I don't even click, I just click with the mouse once. Then it asks me to select my cross-section curves. So basically, in this particular case, I just have this one vertical here. So I'm going to click that, and I'm going to click enter. And you see what it's done. The sweep 1 rail options come up after it's allowing me to preview it. Similar to how the Loft works, where it lets you preview it before you can click OK. So I could manipulate various things within here. And again, there's other options for rail, depending on, again, the complexity of the curves or the other cross sections that you're using. But for right now, freeform works just fine. So let's say, I'll cancel this. Let's say that I have a curve on the other side that's a little bit taller than the first curve. So what this is going to do if I do a sweep 1 again, you can use the bottom curve as the rail. Now I'll select this and this as the cross-section curves, and what it should do is actually blend a surface from the lowest point of this curve to the highest point of this curve. So what it's nicely doing here is creating a smooth transition from this edge to this edge using the reference curve that we made. So that's, again, can be very useful in quickly kind of drawing up unconventional shapes. So that will work also, even if we have this not on the vertical, and this is where it starts to become pretty dynamic. Let's say that this curve is this way, this curve is, this point is moved this way. So we have kind of a full dip in the surface here if we were to do sweep 1 again. So let's select that base rail, choose these cross-section curves, and again you're going to see it blends the curve, blends the surface up, and it makes sure to fully go through the edges of the cross-section curves that you're commanding it to use. So there's a high level of accuracy with using this command. Also, let's just delete that real quick. Let's say we have another, just like with Loft, another control point, another control line rather in the middle. So you can have as many cross-section lines as you want. Again, depending on the need of, or the accuracy needed to pull it through your rail curve. So let's say sweep 1, select rail again, and then we'll select each of these cross-section curves. And again, notice that in each case, it is doing its very best to fully go through those curves that I told it that it needed to use as the cross-sections. So what that does here, in the case of 3, is it creates a little bit less elegant of a transition, but it also allows you to, again, kind of constrict heights of the surface based on whatever detail you might be referencing, or again, other details of the model that you're making. So you can apply a high level of accuracy to the surface that you're creating with this command. So let's go ahead and cancel that. And let's look at sweep 2. It's another option. So what that actually does is, again, we'll put another kind of crazy curve at the top. We'll move him around a little bit compared to the bottom one. And now if I were to type sweep 2, now it's asking me for first rail, and then it's going to ask me for a second rail. So now what it's saying is, okay, these now, anything along these two lines, it's got to connect to both of these lines. So these lines, in a way, it's even more controlling than the first sweep 1, because the surface will have to make sure that it hits every point on this line and every point on this line, kind of like with loft. So now it's asking me for those cross-section curves. I can use this vertical, and it should create something, again, that goes through each point on those lines. Now, it looks, again, pretty close to what we did with sweep 1, but it allows you to just add another layer of accuracy in that you're doing it on the top and the bottom. Let's say, for example, I had a shape here that was much less conventional. Something pretty weird in and of itself. So now let's say I were to sweep that. Sweep 2, choose these two rails, and then choose this as the cross-section curve. And look at much crazier. And notice too that because of the tightness of some of the curves on the cross-section, as it tries to pull itself through the curves I've created here that are rails, it's actually unable to do it in a very accurate way on some of these moments because the edge of this is too tight. So that's something to keep in mind. Either you need to rebuild the surface itself so that it's, in this particular case, you're rebuilding it to a lower degree of accuracy. It's using these as a reference, but it's not tightly pulling itself through the cross sections. If I were to up the number of control points, it's going to try to more closely adhere to that. But you see, again, it's struggling a little bit with some of the accuracy there. So back to not simplifying it. This is where the inputs that you are creating for these surfaces to sweep have to be bound by some level of control and kind of a tolerance that, again, you'll probably have to test it yourself, but you'll see in some cases that these intended cross-section curves may not create, you may not be able to create the surface as accurately as you wanted to in this way. So there's other ways to build the surface other than sweep. Let's try blend curve. Actually, this is a kind of a two-part here. So let's say we have a curve over here. This is just going to be a reference point. And let's say we have a curve over here on the other end. And they're in different planes. But let's say I want to create a line that kind of blends between these two, and then use that line to extrude it into a surface or create another shape in the scene. So I'm just actually going to delete this reference right now. I'm going to say blend curve. So when I do that, it asks me to select curve to blend. So I can select this and this. And now what it's doing is it's actually trying to find, just like the sweep command, kind of an elegant completion to those two curves. So as, again, just like with loft and with sweep, I can adjust how the curves are being created by toggling some of these various continuity buttons here. So right now it's set to curvature, but if I set it to position, on both points. It's literally just drawing a straight line from point A to point B, from point 1 to 2. So that's a little less interesting than, say, the tangency here, where with tangency on, at least what it's doing is creating a smooth curve transition between the top point and the bottom point. And in this way, you can again have a high degree of accuracy using different points in space to create the line that you want. And then that line can, again, that could extrude into its own shape. Or we could use that to, we could copy that over and we could loft it. Right? Or we could add a cross section to it. And whether that's, we can sweep with that. So select rail and then select cross section curve. So again, multiple ways to kind of get to these different surface creation commands. Let's just stay on blend curve for a second. So another way that this works, this will work with curves that are perpendicular to one another. So let's say that we have this curve out in space here, and we have this curve here. So I could connect these. I could type connect, and it's just going to create a straight line connection between these two curves. It's kind of like chamfer. I could fillet it, and a fillet will create a rounded edge where the two curves meet based on the input for the radius that I have created. This is similar to some of the CAD commands. They do this as well. In that particular case, the radius looked like it was a little too big. So if we try that again, maybe we type 1 foot. Try that again. Oh, you know what it is? I think these are not in plane with one another. So if we were to draw these in plane with one another, that should work better. Still being uncooperative, but you get the idea. It's creating a curve that allows these to, in theory, meet one another, not at a straight point. So to further the point here, the blend curve should work in the same way that we had it in 3D. Let's say we have this a little further away. The fillet command is maybe a little less intuitive here. If we say blend curve, select, again, it should create kind of nice extension that draws these two together. And I can adjust actually then, if I hold shift down, it'll allow me to pull both sides of the curve up to the point that it's maintaining, for the most part, it's maintaining tangency here. If you notice here, if I pull past the 2 points past one another, it starts to create kind of an inverted situation. But up to that point, it's still keeping kind of a nice elegant curve. I could also, if I just escape out of that, again, I could change how the curvature is working. If I don't hold down shift as I'm doing this, it'll just adjust the 1 point at a time. And then position, of course, would just have it be the straight line again. So again, some different ways to draw control curves and support curves that you can then use to extrude up into accurate surfaces. So a couple other surface commands that we'll look at here real quick. So going back to the base curve that we had, we can run a command called patch. Actually, before we do patch, let's do one that's a little bit more accurate. So if this is a network surface, so what this is going to require is actually, it's going to ask for 4 different curves rather than just 2. So again, let's just pull this a little bit out of the way of our base. And then in this particular case, let's draw our kind of interesting edge, maybe a little less, notice that it was out of plane there. maybe a little less wonky than the first one that I had drawn that was causing us problems with the sweep command, but just to give us a little bit of relief to the shape. And I'll connect all these corners. So the network surface command requires that you have all the points touching of the 4 lines for it to be a really accurate construction. So if I were to type network surface now, this is going to probably create the nicest surface out of these 4 curves. Select curves in the network. So basically, again, kind of in sequential order, selecting each of these. And so it will ask me, again, I can adjust the position, I can adjust the looseness of the edges. Let's click preview and see what this looks like. So you'll notice here, this is doing a pretty darn good job of connecting to every line, every point on each of the lines that were created. It's doing better than the sweep command did with some of the transitions from this shape to that shape on either side. And you can see kind of just from the number of subdivisions on the surface that it really is thinking hard about how accurate this is to these different curves. So again, the surface, this command is maybe the most accurate. The network surface is maybe the most accurate as it relates to the niceness of the surface. I shouldn't say accurate. Each command is accurate in its own way, depending on the need of the user. But this one creates maybe the most robust surface that sort of as closely as it can matches the edges that you've drawn. So, and then the last one that we'll do here is patch. Patch is patch can be useful, but patch, what it does, as we see, let's see what I patch through these 4 points. Preview. So patches, it's doing something similar to the network surface, but it's not doing it in quite as accurate of a way. You can see along the edges that it's actually not connecting to the lines that it's creating. And if I were to, I can manipulate this so that it has more spans in the U or the V direction, which should help it fit a little bit more. But it's still, it's just much less accurate, because what it's actually doing is it's implying that there's a much larger surface out in space, and it's just filling and creating a surface out of the window of lines that you've made. So it can be useful as it relates to sometimes landscape related endeavors, sometimes capping a surface or an open edge in an unconventional way. A patch will work better than a network surface or a loft or a sweep, in part because it's going to be a little bit more adventurous in guessing how to create that surface with less information. It just has a lower degree of accuracy as a result. So again, patch absolutely can be useful. It just varies a little bit from some of these other surfaces that we made. So that's just a very brief covering of some of the common surface commands and how you can kind of manipulate them. And we'll create a couple other videos here shortly that address different ways to add some solidity to these surfaces and continue to add detail to your models that you're working on.